Hello everyone, I hope you are all doing well. In this short video, I will try to explain how we can run post-stack seismic inversion. So as I have already explained, so initially we have to open the software, and in the software we can have the different projects. If we don't have project, then we have to find a project, or we can create new project. Once we create the new project, then we can import well logs through import wells, and here we can import last files, and this is where we can load the seismic. So here we can import seismic from SegWi. Once the data is loaded, then we can have maybe pre-stack gatherers and we can have post-stack gatherers. And if we want to do anything with this data or any kind of operations, then we can simply go to processes here, and for example, we can stack our gathers to make them stack sections. So here we can go to seismic data processing, and here we have stack, CDP stack, and then we can stack the seismic, and this is how data when it will be stacked. So once the data is ready, so here we have seismic and here we have well logs, and as I explained, the logs, they are now in time domain, but they are converted from depth to time using probably default velocity, which is not the correct one. So now, since we have the seismic and we have the well logs, then we can go and run the seismic conversion. Seismic conversion, we can find it in the workflows. In the workflows here, we can go to post-stack seismic conversion or post-stack conversion. Then we can select our stack section. And here it was red, it becomes black. Then we select horizon, and here we don't have any. We have one single horizon, but if we want to pick more horizons, then we can go and pick horizons. So here I can name it, for example, horizon top, and this will be picked on this CDP stack. Then I will press OK, and here it's asking me if I want to display it on map view. I don't want, because it's simple 2D seismic, so no need for that. And then and here I have to pick my horizon. What is the action is picking, and the mode I will choose the left and right repeat, which is like an auto picking mode in Hamson Russell. And here, what do I want to pick? Is it trough or peak? So I will choose trough, because I know my reservoir will be a trough or a negative amplitude. So then I can go and select trough. Okay, and then I can add the colors if I want, the stack, so that I will be able to see what is the trough and the peak. And you see here it's negative, so it means here I'm picking the trough. Now once I'm doing I'm done with the picking, I can just press OK, so my horizon will be saved. Next step is to go to the extract the statistical wavelet. Yeah, statistical wavelet will be extracted from my seismic. So then I will choose my seismic, and then my entire seismic trace, and the name, and the wavelet length is 200 millisecond, and then I will just run. So this is my wavelet extracted from my seismic, which is clear, it's zero phase. Okay. Then next I go to the wells. I will select my well, which I will be using for my seismic inversion, and this is my well. I have one single well that I will be using for this inversion. Okay, and then next I go to the well to seismic tie, or the well correlation, and here is correlate the wells with the seismic. So I will choose my CDP stack or my seismic sections. Then I will choose here the zero offset synthetic, and then I will press OK. So this will be my cross correlation uh, diagram or plot, which will show me how similar is the synthetic with my um, real seismic trace. So this is the real seismic trace. Is duplicated 5 times and is taken from the well location here. And this one, the blue one, is the trace which is generated um, from the well logs. So now what I will do, I will try to match this with this. Okay. So I see that initially, if I run a shift to the synthetic um, by 51 millisecond, I will have a correlation of around 56%. Let me try to apply this shift and I see if it is enough or not. So by doing that, I could get correlation of almost 58%. If I feel it's enough, then I can stop. If I'm not, then I can improve it. So for example, I will stretch a little bit my synthetic trace to match it with the real trace and to improve my correlation. And I will apply stretch. Now I see that I have improved my correlation. I can do it again so that I can improve my well to seismic tie. I see here I have reverse polarity. So here I have positive, which is in real seismic is not existing at all. So I don't have any reflection from the real to match it, so I can just leave it. Okay, and then I will apply stretch. So if I'm happy with this correlation, I can go ahead with it. Okay, so now I'm done with my well to seismic tie, and I see that my well now is at its a good position. I can go now and I can insert tops. So top selection, I can show all the tops. Top appearance, I choose show name on the left and I press OK. So now I see that the top of my reservoir and the bottom of my reservoir. I go to build my initial model. So I will choose my CDP stack and my AV well and my horizon. So this is what I need. I need a seismic well and the horizon. Then I run it. So when I run it, this is my initial model or low frequency trend. Next, I can run the seismic inversion at the well location. Of course, again, I will use the same seismic and my AV well and my wavelet, which I extracted earlier. And then I check here if I want to edit or modify any of the parameters. Here we have different types of inversion. We have model-based, band-limited, colored inversion, linear programming, sparse spike, or maximum likelihood sparse spike. So I will leave it model-based inversion, and then I will run it. So here I can notice that they have a very good match between the synthetic and which is generated from the logs after 10 iterations that we have seen earlier. And this is the real seismic, and this is the mismatch or the error. I have very low error and very high correlation. So if I'm happy with these values at this well location, I can move to other wells. But because I have only one well, so I will go directly now to run it on my seismic. So to run it on my seismic, I just go here, or I go directly to apply to volume, which is the same thing. So my input seismic is my CDP stack, and um, my inverted seismic, it will be called inverted, and they will be using model one, and the wavelet, it will be statistical, and the workflow, it will be model based. The number of iteration is the same as we have seen in at the well location. Then I can just run it. So when I run it, Then I will have my seismic inverted section. So this is the low frequency impedance, and this is the final inversion, and this is the difference. So for example, I can bring my seismic here. Okay, so you can hide the color key here, and this will be my seismic, and this one will be my well logs, and this is the seismic inversion. So with this, I can conclude, and I'm done with the seismic inversion. In terms of interpretation, you can play with the range. So I see here, for example, that at the gas zone, I do have low impedance, which is very clear, and I can make it even better than this by playing with the colors. So I see that the gas zone has a low, very low acoustic impedance compared uh, to the overlying formation. Okay, and here this is my seismic. So the seismic is showing me an interface property, which is a contrast between the layers, but the impedance is showing me the layer property. Okay, so that's it for the seismic inversion, and thank you for your attention.